This one maybe will show you that we can use the chain rule to find something otherwise impossible. For instance, f of x, shouldn't say impossible, but if you try to find the derivative of this function using the limit definition, then you'll have a hard time doing so. Okay. This is the cube root, and the polynomial inside is x squared plus x plus 1. And of course, we need to find f prime of x. Okay, let's do f and g here. Notice that I'm mixing both notations. So we're going to say that f of x is f composition g of x. Okay? And remember, the derivative f prime would be f prime of g times g prime of x. So f of g, well, if I choose g to be x squared plus x plus 1, then f of g will be simply 1 over the cube root of g, which I can write as g raised to the power of negative 1 over 3. Right? And therefore the derivative f prime of g will be the power negative 1/3 g, and as you subtract 1 from negative 1 over 3, you have negative 4 over 3, right? Are we okay with this so far? And bring it back to radical notation, then it will be negative 1, the cube root of g to the 4th. So this will be g prime, f prime of g. On the other hand, this one is a piece of cake. G prime of x is going to be simply x, 2x plus 1. So basically you need to multiply these two to get the result. So f prime of x will be f prime of g, which is negative 1 over the cube root of g to the 4th. That will be f prime of g, and then g prime of x is 2x plus 1. And now to bring it home, we need to write everything in terms of x. So we have 2x plus 1 on top, and at the bottom there is a 3 somewhere which I left out. There is a 3 right here and right here. So you have 3 times the cube root of x squared plus x plus 1 to the 4th power. And this one sitting inside the radical. Now imagine trying to obtain this result using the limit definition of the derivative. In other words, the limit as h goes to 0 of f of x plus h minus f of x divided by h with this kind of function. So the chain rule is one of, it's a very powerful rule that allows you to find the derivative of rather complex functions.